To comply with California's Building Energy Efficiency Standards, or ENERGY standards, covered processes must meet all mandatory measures and applicable requirements of either the prescriptive approach or the performance approach. This course covers the prescriptive requirements for commercial kitchens. These requirements apply to new construction as well as additions and alterations where applicable. Critical to both safety and comfort, commercial kitchen ventilation systems are designed to remove heat, moisture, and smoke. To balance health and comfort with energy use, ventilation systems must be designed and operated to provide effective ventilation without consuming excess energy. First, we will review the requirements for kitchen exhaust systems. Kitchen exhaust systems use hoods to capture and remove heat and smoke from cooking. The ENERGY standards require that replacement air introduced directly into the hood cavity not exceed 10% of the hood exhaust airflow rate. Studies have shown that exceeding 10% greatly reduces the effectiveness of the exhaust hood. The ENERGY standards have requirements for Type 1 exhaust hoods. Type 1 hoods are designed to remove heat, smoke, condensation, and other greasy byproducts of cooking. Type 1 hoods are installed over cooktops, grills, and fryers. The hood's filter captures grease and other contaminants before the air is exhausted outside. In contrast, Type 2 hoods remove only heat and moisture and are installed above commercial dishwashers and pasta cookers. Kitchen facilities with a total Type 1 and Type 2 hood exhaust airflow rate greater than 5,000 CFM must meet ENERGY standards requirements for Type 1 hoods. Each Type 1 hood must have a maximum net exhaust flow rate that does not exceed the airflow rate per linear foot of hood length, specified in Table 140.9-A. The table specifies the maximum net exhaust flow rate based on the hood type and the type of cooking equipment. ASHRAE Standard 154-2011 defines hood and equipment types and net exhaust flow rate. If a single hood or hood section is installed over equipment with different duty ratings, then the maximum net exhaust flow rate allowed is the value listed for the highest equipment duty rating. For example, if a single island canopy hood exhausts air from both light and medium duty equipment, 350 CFM per linear foot of exhaust is allowed. There's an exception to the maximum net exhaust flow rate when 75% or more of the total Type 1 and Type 2 exhaust air is transfer air from other spaces that would otherwise be exhausted. Existing hoods that are not being replaced as part of an addition or alteration are not required to satisfy one of the 4 compliance options. Now we will review the requirements for kitchen ventilation. Ventilation for kitchens can be optimized to use ventilation air from adjacent spaces such as a dining room. Mechanically cooled or heated makeup air delivered to any space with a kitchen exhaust hood must not exceed the greater of either 1. The supply airflow required to meet the space heating or cooling load, or 2. The hood exhaust airflow minus the available transfer air from adjacent spaces. Available transfer air is the portion of outdoor ventilation air serving adjacent spaces that would otherwise be relieved from the building and is not required to maintain pressurization of these spaces or to satisfy other exhaust needs, such as for restrooms. This requirement does not apply to existing kitchen makeup air units that are not being replaced as part of an addition or alteration. For example, in this kitchen located adjacent to a dining room, the required outdoor air for the dining room is 6,000 CFM, which exceeds the 5,000 CFM required for the kitchen exhaust. The 5,000 CFM of ventilation air required for the kitchen exhaust is transferred from the dining room, and no outdoor air is supplied directly to the kitchen. The remaining 1,000 CFM of ventilation air is exhausted from the dining room. When a kitchen facility has a total Type 1 and Type 2 hood exhaust airflow rate greater than 5,000 CFM, the kitchen ventilation design must satisfy one of 4 compliance options. The first option is to use available transfer air from adjacent spaces to provide at least 50% of replacement air for the kitchen, such as shown in the previous example. The second option is to include a demand control ventilation system on at least 75% of the exhaust air. The demand control ventilation system must include controls necessary to modulate airflow in response to appliance operation and maintain full capture and containment of smoke, effluent, and combustion products during cooking and idle periods. The demand control ventilation system must be capable of reducing the exhaust and replacement airflow rate to the larger of either 50% of the design value or the mandatory ventilation rate specified for non-residential buildings, which is explained in detail in the course on this topic. Generally, the minimum mandatory ventilation requirement to satisfy occupancy loads in commercial kitchens is 0.15 CFM per square foot of floor area. Upon cooking sensor failure, the demand control ventilation system must include fail-safe controls that operate the exhaust system at full airflow. The controls must also include an adjustable timed override to allow occupants the ability to operate the system at full airflow. The third option is to use energy recovery devices that recover heat between the exhaust airflow and the replacement airflow. The energy recovery device must recover at least 40% of the sensible heat from at least 50% of the exhaust airflow. Finally, the fourth option is to minimize conditioning of at least 75% of the replacement air for the exhaust system. To satisfy this option, the replacement air has to be either not heated or heated to no more than 60 degrees Fahrenheit and not cooled or cooled without the use of mechanical cooling. Existing hoods that are not being replaced as part of an addition or alteration are not required to satisfy one of the four compliance options. Before an occupancy permit is granted for a commercial kitchen, the equipment and systems must be certified as meeting the acceptance requirements for code compliance, as specified by the reference non-residential appendix NA7. A certificate of acceptance must be submitted to the enforcement agency certifying that the equipment and systems meet the acceptance requirements specified in NA 7.11. This concludes our review of the Energy Standard's prescriptive requirements for commercial kitchens. To find more courses and additional information on the Energy Standards, please visit the California Energy Commission at energy.ca.gov. Thank you for watching.